All right, so today I'm going to start with the exam. Um, I'm actually grading it. Okay, I'm halfway done, so I think I should be able to get it done today. Um, so anyway, I just want to go over all the answers to the exam, just to make sure that everybody understand why the answer is the answer. So we'll go ahead and get started with this particular version. There are many different versions, but this is one of many. All right, so we're going to proceed to talk about question number one first. So question number one is there's not really a whole lot of trick to question number one. Um, basically the trace is on this side, okay? On the right hand side, this is the full trace of question number one. And I don't know what questions you guys might have, but it's fairly straightforward. On line 32, x gets a value of 0. And then on line 33, z gets a value of n minus 1, n is 5, and that's why z gets a value of 4. And then on line 34, we add 1 to x, x becomes 1. And then on line 35, we evaluate the condition, x is less than z, and if x is less than z, which it is in this case, then we continue with the loop, 1 is less than 4, and then on line 36, we evaluate the condition to see if a bracket x or element x of a is greater than element z of a. So looking at the value of x versus z, so we are comparing a bracket 1 with a bracket 4 in this case. 17 is in fact greater than 5. So we go into the then portion of the conditional statement starting on line 38. So on line 38, here we store 17 in variable u because that's what it's calling for. And then on line 39, we change the value of a bracket x with a bracket z. So that means the value of 5 is used to overwrite the value of the 17. So the 17 is gone at this point. And then on the next line, we use variable u to update a bracket z. Variable u currently has a value of 17 because that's what we stored, and then we use it to overwrite a bracket 4. So that concludes line 30, line 40. Okay, that concludes line 40, which is here. And then on line 42, we continue here. So one person of the entire class made the mistake of exiting the loop when the condition of line 36 becomes false in the next iteration. So that is not supposed to happen. Okay, you'll be supposed to continue with the loop, but I will show that like next. And then we add 1 to x, so x goes from 1 to 2, and then we subtract 1 from z, so z goes from 4 to 3. Quite a few people did not do that. Okay, quite a few people kind of missed these two lines over here. So they finished the conditional statement or the then portion of the conditional statement and did not perform the statements that are after the conditional statement. So for those particular programs, the um, I don't even know how they exit because without incrementing or decrementing one of these two, the condition should never become true. So after that, we go back to the main loop. So the main loop is still asking whether x is less than z, and because x is a 2, z is a 3, so 2 is still less than 3, and as a result, we go into the loop again. For the second iteration, this condition should be false, because we should be comparing a bracket 2, which is a 3, versus a bracket 3, which is a 4. 3 is greater than 4 is false. And as a result, we skip over the entire then portion, and then we perform the line 43 and line 42 and line 43 again. So x increments from 2 to 3, z decrements from 3 to 2, and then when we get back to line 35 to reevaluate the condition of the loop, x is less than z is now false, and as a result, we go to post at that point. So that's pretty much the full trace of question number one. So do we have any questions about number one? Question number one. No questions. All right. Um, yeah, I can do a little statistics later on to kind of tell you guys, how people do on each question, or at least what the mean is for the class. So now we move on to question number two. So there we go. Question number two. Here we go. So question number two is deceptively simple. The code is deceptively simple. Um, the trace is not as short as someone might think it is, but it is not an infinite loop. Okay. Many people concluded that question number two should end up as an infinite loop, but that is not the case. Okay. So we'll go ahead and figure out why that is not the case. And you can see that only one variable, which is w, is changed for all the iterations because everything is fixed for the from the beginning. All right. So everybody, or I shouldn't say everybody, but most people have a different configuration of these numbers here. It doesn't matter. Okay. The mechanism to answer this question is exactly the same, even though these numbers are different. And I forgot to put a five here. That's uh, it should be a six in here, seven in here. There we go. So I forgot, my script forgot to put a seven here. I can fix that. All right, so W is initialized to zero. W is the only variable that changes over time. It is initialized to zero, and N is not even needed in this question. Okay, if you look at this entire code, it does not depend on N at all. Okay, so that means if I don't specify what N is over here, it doesn't change whether you can work on the algorithm or not. All right, so I think the most important part is how do we evaluate something like this? Okay, so I did not specifically tell people how to evaluate a nested index, but we know how to do one indexing. So basically it is a single indexing, but do it twice. Okay. So the way you look at this expression, the one that is highlighted here, is you ask, okay, how do we evaluate this overall expression? And the overall expression is saying, okay, we are going to access an element of y. That's basically what this part is saying. And it's saying, we need the index to be whatever is inside the outer square bracket. So now we ask, what is inside the outside square bracket? It is this portion here. So that means we have to evaluate this part first. Okay. But this part is really kind of asking the same question because this part, which starts with y and then an open square bracket, is asking, oh, we are trying to access one element of y, and the element that we need to access in y in this case is determined by w. So now that we know w has a value of 0 to begin with, so we get to y bracket 0, which is a 5. And then what we do is we put the 5 back into this space here. So now we are trying to access y bracket 5. Y bracket 5 has a value of 4. So that becomes the entire right-hand side of the assignment operation. And we use that 5 to update to w. And that's why excuse me, we use the 4 to update w. And that's why w becomes 4 at the beginning of the first iteration of the do while loop. Is that okay? So that is the key, okay? Because once people figure out this thing here, then they go like, oh, okay, so when we get to the while statement over here, w is greater than 0 because w is 4 right now. So the condition is true. We have to go back to line 10 and then you do the whole thing again. Quite a few people, okay, of the ones that I have graded up to this point, quite a few people did not even get to line 10, to say that, we are actually updating W to something that is non-zero, and then make the conclusion that this is an infinite loop. So if I cannot see the rationale behind why they think this is an infinite loop, I cannot give any credit. There's no point for mentioning that this is an infinite loop. A few people got the whole thing right. Okay, so congratulations to those people. And then a few people did make two people so far made the mistake of using a single bracket. So they basically evaluated as if it is like this. So I gave those people partial credit because they showed that they know how to do indexing, except they did not do the double indexing instead. So they still get partial credit. They still get a good amount of points. And then a few people made some calculation mistakes along the way. So instead of this particular sequence, it was shortened because they made the mistake of, oh, okay, this value should go here. So I also gave those people, some partial credit because they illustrated that they know how to do it, except they just made a few minor mistakes along the way. So the loop does not conclude the way that it is shown in the key. So do we have any questions about question number two? Okay. So what do you think I'm trying to test in question number two? And you don't have to say it out loud, okay, but I do want you to think about it. I'm trying to see if you know how to look at something that looks like something they haven't seen before and still be able to figure out how to do it. Because this one is really just saying, okay, the outer one is indexing, but the expression to specify the index is specified by whatever is inside, which turns out to be also an indexing expression. So, to figure out the dependency, which one to evaluate first, and then use the result of that evaluation to evaluate the other one, that is basically what I'm testing in this case. All right. Shall we move on to the third question, or do we have any questions about number two? Yep. In in line 10, what about it? I just explained it. Okay. So I'm not criticizing, okay? But when I explained it, you did not quite understand what I said and that's why you're asking the question now. So can you specify which part of the explanation was you're missing? Yes, you are talking about this four over here. I just explained it. Okay. So that means something is missing either in the way that I explained the answer, okay, or something else, okay? So the way I explained that was W was a zero to begin with, right? I'll be accepting that W starts with a value of zero because that's how it was initialized here. So by the time we get here, this W is a zero. So what is Y bracket zero? So this time I work on this from the inside out. So what is this expression? Just the part that I have highlighted. So I want you to evaluate it because you asked the question. So can you tell me what is y square bracket w, knowing that w is a zero? So you're not quite getting what is array indexing by itself. So array indexing means your y is an array, and whatever expression we specify inside the square bracket tells you which element of the array we want to access. And because w is a zero right now, so we go to y and then we specify y bracket zero here. It has a value of 5. So are we okay with that? So once we know y square bracket w is 5, so we put the 5 in place of the expression that is highlighted here. So now we are accessing y square bracket 5. So y square bracket with a 5 inside the square brackets means we have to go here. This is y bracket 5, and we can see that y bracket 5 has a value of 4. So that is why the entire right-hand side on line 10 evaluates to 4. This entire thing evaluates to 4. So that's the right-hand side, and we update the left-hand side with the right-hand side, and that's why w ends up with a value of 4. So are you okay with that explanation? Okay, excellent. All right. So, okay. Any other questions about number two? Okay. I see some people shaking their heads violently, so we shall move on until before their heads, kind of fall off because of the violent turn shaking. All right, so question number three. Question number three is okay. So for this one, most people, who did not get full credit, they did not understand line 45. Okay, so line 45 is kind of the problem, okay, with some people with this question. But we're going to start from the beginning, and then by the time we get to line 45, which is here, then I'll slow down and explain that. Okay, so we start with line 41. So line 41 says, okay, z is initialized to false. That's exactly what it's doing here. Line 42 wants to initialize x to be a 0. We got that. And then on line 43, we initialize w to also do a 0. So that part almost everybody got. Okay, nobody made a mistake here. And then on line 44, we evaluate this expression. Z, oh, I forgot a not over here. So it's not z and x is less than n. Um, And most people did, got this one correct. Okay, it is true the first time. So we get into the loop on line 45. Line 45 is the problem. So how do we read line 45? Okay, so let me ask this question. When you read this entire portion, what is it? How would you describe this entire thing? First of all, if I highlight this portion here, is it a statement or is it an expression? It is a statement. Is a statement because it ends with a semicolon. So this is going all the way back to the no, BNF. Okay, it goes all the way back to the BNF notation. So this is an assignment statement. Okay, within an assignment statement, we have an assignment expression, which is this part over here. Okay, let me highlight it correctly. So this is the assignment expression. And of an assignment expression, we have two parts, right? We have the left-hand side, and then we have the right-hand side. So when I talk about the left-hand side versus the right-hand side, it would be the left-hand side to the single equal symbol. And when I refer to the right-hand side, I'm referring to the right-hand side to the single equal symbol. So that means we break it into two halves. This is the left-hand side, and then this entire thing is the right hand side. Okay, so if that entire thing is the right hand side, then we have to evaluate it first, because an assignment operation says we evaluate the right hand side. Whatever the value of the right hand side is, we use it to update the left hand side. So that's what we need to do. So what is this expression here? Just the highlighted portion, what is it? How would you describe it? So I'll give you a few alternatives. Are we, is this entire thing, if you look at the last operation, are we multiplying? No, we don't see the asterisk. Are we dividing? No, we don't see the slash. So what is it? What is this symbol here? What is double bar representing? Or, very good. Okay, so the whole thing is an or operation. So with the or operation, it has a left-hand side, which is just this portion here, and it has a right-hand side here. Okay, so what do you need to do to make an or true? Under what conditions is an or expression true with respect to the left-hand side versus the right-hand side? At least one side has to be true. Okay, so if at least one side of the or is true, then the whole thing is true. So now we go in, we look further into this one. Okay, so we look at the left-hand side of the or, which is z. Z was initialized to false, so that is false already. But just knowing the left-hand side of an or is false, can I conclude the entire expression is false? We cannot. Okay, so we have to evaluate the right-hand side. So when you look at this portion here, what is it actually doing? Focusing on the double equal. So what does double equal represent as opposed to single equal? Comparison. Comparison, and we're trying to confirm whether the two sides are the same or not. Okay, very good. So now we have to compare the two sides of the double equal. The left-hand side of the double equal specifies a bracket x. X currently has a value of 0. A bracket 0 has a value of 25. The right-hand side of the comparison for equal is u, and variable u does not change. It has a value of 11. So the question now is 25 the same as 11? The answer is false, right? So that means, this side or the right-hand side of the or is false, and so is the left-hand side. So if both sides of the or are false, what happens to the value of this entire expression? It is also false. It remains false. Very good. And as a result, z gets updated to false again, for the first update after the initialization. Is that okay? All right. So because it is false, we still have to evaluate this expression. Okay, so we still have to evaluate the condition of the condition of the condition of the conditional statement. And z is now false, so that means not z is true. If not z is true, then we perform the only statement inside the then portion, which is this portion here. Most people got this part right. Okay, so most people know, okay, we need to retrieve a bracket 0, add it to w, and then change the value of w as a result of that. So most people got that, not a problem. And then after that, we go to line 49, which is down here. Line 49, most people got it right too. We are just adding 1 to x. X goes from 0 to 1. And then we go back to the very beginning here. And most people got this one just fine. Remember, I'm forgetting an exclamation point here. So we are re-evaluating not z, because z is false, not z is going to be true. And then we evaluate the right-hand side of the and. X currently has a value of 1. N always has a value of 3. 1 is less than 3 is also true. So we have true and true, which is also true. Then we go back to line 45 again. But this time, something is different, okay? Because even though the left-hand side of the or, which is z, is still false, okay, to begin with, the right-hand side is now true, because in this case, the right-hand side is comparing a bracket x, but x has changed. X is now 1. So a bracket 1 has a value of 11. U always has a value of 11. 11 equals to 11 is true. Yep, that's right. So the right-hand side of the or is true. The left-hand side of the or is false. So we basically are evaluating what is false or true. What is false or true? True, exactly. So that's why Z is now updated to a true here. So this is where a very small minority of the exams that I have graded reflected correctly. Okay, quite a few people evaluate the expression to be false. So basically, Z gets updated a few times, but every single time it got updated, it is still false. So those programs or those traces would go through more iterations than it needs to, because knowing that z is true at this point, so when we get to line 46, and we ask what is not z, because z is true, not true is false. So that means we don't even perform the body of the, or I should say the then statement of the conditional statement. So that way it skips to line 49. 49 will still add 1 to x. X increments from 0 to 2. But when we get back to the beginning of the while loop, okay, which is which is over here, z is now true. So that means not z is going to be false. In a conjunction, if the left hand side is false already, the whole thing is concluded to be false. And as a result, we exit the loop and then we get to post. So for people who kind of missed line 45 and did not change the value of z from false to true because of this, they still get partial credit. They still get a healthy portion of the partial credit, because they still know that it needs to be updated, but they just did not update it correctly. Okay. Um, but there are quite a few people did not even update the variable z. So more points are taken off you for those particular answers. All right, so that's for exam two. Any questions? Any doomsday question? Like, what if I totally flunk exam two? What's gonna happen to me now? A few nods. Okay, so that goes back to the syllabus. Okay, did you guys read the syllabus and reread it? No. Okay. So what are the thresholds for this class to get a C? So if you look at all the points that you have gotten using all the homework assignments and also all the exams, okay? So that's a score, and then you divide it by, all the possible points, okay? What ratio do you need to get a C out of this class? Hmm? No, it's actually lower than that. Okay, so I'm going to do something that is super annoying, which is I would actually go back to my own. Where's my browser? I cannot. Okay, why doesn't it show up? Well, it's all right. All right, so here's the syllabus. Okay, so in the future, in all of your other classes, okay, you may or may not be taking classes from me again, but when you go take other classes, you need to really read the syllabus and remember at least the key points of the syllabus because some people may be panicking for no reason at all. Because right here it says grading, assessment. I cannot remember where the thresholds are specified. I can just go here and scan. There we go. All right. So 2/4 is the center of a C, but the thresholds are specified here. Okay, so these are the thresholds. So because of this class, can we read this portion now? Can we understand this portion? Okay, X is representing the actual percentage or the actual ratio of how many points you get out of this class. So for people who receive less than 12.5%, they're going to get an F out of this class. I think that's pretty hard to argue against. Okay, for people who get 1/8 or less than 1/8 of all the total points of a class, those people are getting Fs, which means it's not a judgment against those people. It simply means those people may need to take the class again. They're not ready for the next class. Okay, that is the point. They're not ready for the next class. So for people who are getting less than 37.5%, they're getting Ds. Okay, so they're also not ready to move on to the next class. For people who are getting at least 37.5% but less than 62.5%, those are the people who are getting C's out of this class. So 37.5% is the threshold. Are we doing okay so far? All right. And to get a B, you need to have at least 62.5% to get a B. To get an A, you need at least 87.5%. So those are the breakpoints. So what do you think is the worst grade someone can possibly get out of this class? The worst grade from the perspective of a student who is on the track of the computer science program with the hope of getting a career in computer science, because I'm assuming that's what people want to do. So what is the worst possible grade to get out of this class? Yes. Hmm? A D or an F? No, it is a C. A C is the worst possible grade to get out of this class because a C means they are not failing, okay, which seems to be good. It is actually really bad because those people cannot retake this class even if they wanted to. Let me say that one more time because I think some of you are not believing what I just said. The the bad thing about getting a C is those people cannot retake the class. Then you might be thinking, why would anyone want to retake this class, especially from tech? Because a C means you those people barely have enough knowledge to quote unquote pass the class. Are they good at what this class is trying to teach? Probably not. Okay. So that means those people are moving on to CISP 360 with a somewhat shaky foundation of programming. And what do you think, those people would experience if they do not, put in some extra effort in CISP 360, the class that's right after this one? They will find CISP 360 more challenging than it needs to be. So that is the reason why I said a C is the worst possible grade out of this class. Because they pass the class, they cannot even retake the class even if they wanted to, and they move on to CISP 360 with what I would think as a somewhat shaky foundation instead of a solid foundation. Now, the B's, I'm not worried, okay, because if I were a student in this class, of my own class, I would probably get a B because I'm careless, okay? I would make stupid mistakes left and right, especially in an exam. So I'm pretty sure that I can only get a B out of this class. So A and B's, no worries. They're solid. They're ready to move on. C's, a little bit shaky. Okay, so I would actually worry about those people. D's and F's is no big deal. Take the class again. From me, from somebody else, doesn't matter. Okay, just take the class again. It is not a judgment against you. It is simply saying that if you move on with what you know or what you can do at this point, you will really can you're going to have a really hard time in CISP 360. That's what the D and the F means. Okay, it is not a judgment against character. It is simply saying that you know you have to have a better foundation before you move on. So that's how I would see this. Okay, but I'm still not addressing the people who are thinking, yeah, but my grade right now is really bad. Why do I still have hope? Well, the reason why everybody still has hope has to do with the percentage split of all the assessments. So when you look at the assessments, look at this part here. The first exam or all the homework assignment only add up to 20%. So for someone who kind of, I only get about 10% out of the 20%, it's okay. It's no big deal. The first exam is another 20%. The second exam is also another 20%, and I'm almost certain that I can get it done today. I can grade everything by the end of today. The final exam by itself is 40%. So what does that mean? That means for someone who has not turned in a single homework assignment, completely flunk the first exam, completely flunk the second exam, if they ace the final exam, they will still pass the class. Now, I did not say anything about the likelihood of that happening. I just said that it is possible. Okay. So I don't think anyone is going to get a zero out of all the homework assignments. Okay. That really should not happen. Most people get some points out of the first and the second exam. So that means for the final exam, yeah, you can kind of calculate how many points you need to get out of the final exam to get a C. I would suspect that many people in this class can already pass the class as it is now. Because if you have accumulated at least 40% or 30, excuse me, 37.5% at this point, you're already passing the class with a C. Okay, so for those people, if they are content with just a letter grade of C, they don't even have to come to the final exam. I have never seen that happen. For people who are already passing the class, they always come to the final exam. It's like, oh, I want to bump it up to the next grade because it is by itself a 40%, which means if someone is doing really good in the final exam, and I'm not even saying really good, just good, okay? It's just 25% out of the 40%, which is a little bit more than half, right? They can bump up the grade by one already. So if they had a C, they can become a B. If they had a B, they can become an A. Now, in some cases, the final exam alone can jump by 2 grades. So someone who might have a C right now by all the points accumulated, Nobody can get a B right now, right? Because we only have 60% and you need 62.5% to get a B. So nobody has a B right now. But some people can be really close. So for those people, they can kind of do a fairly good job in the final exam and easily bump it up to an A. So that's kind of how things are laid out. Do we have any questions about, the syllabus or how the point values are, allocated? No questions? Yep, go ahead. Nobody should have a guaranteed B by the end of the semester just because of the three, just because the homework assignments are 20%. The first exam is 20%. The second exam is 20%. So assuming somebody is, oh, okay, I have to take it back. Correct. So without the adjustment, nobody should have a guaranteed B at this point of time. But because I also use the 90 percentile readjustment, so if somebody is consistently being the highest score of the class, those people would have extra credit points from the first and the second exam. So with those counted in, it might be possible for someone to actually have almost a B at this point. But we are not done with all the homework assignments either, so there are still some points to be, added to the homework assignments. Yep. All right. So do we have any other questions about grading, how much weight the final exam is and, stuff like that. Okay. What about resources? Okay. Let's just say that someone realized that I might need some help, with, this material. Where can I find some tutoring, assistance? So what would be the answer to that question? Yeah, counseling won't help you, but Mesa would. Okay, so if you look into Mesa American River College, it is right downstairs. Okay, it's downstairs on the first floor, kind of a little bit to that side of the hallway. So Mesa stands for Mathematics, Engineering, Science Achievement. They offer free tutoring service to people who are qualified. So there's a qualification to become a member of Mesa. So there are two requirements. The first requirement is first generation college student. The second requirement is low income. For people who meet both of those requirements, they can become full member of Mesa, which means they can go on to field trips, all paid for. Sometimes to another state. Okay, so that's kind of cool. For people who meet only one of the two requirements, so either first generation or low income, those people can become quote unquote affiliated members. But even affiliated members can get free tutoring from Mesa. And the tutors in Mesa, they do not just tutor one class, they can tutor computer science, they can tutor math, chemistry, physics, basically everything you need for computer science as a degree. Many of the tutors can basically tutor all of those classes. So it's a really, really good resource. Okay, so if you qualify as a member, I would highly suggest you to go to the Mesa Center, which is downstairs on the first floor. Okay, and get a tutor. Okay, get in touch with a tutor. So that's a resource that you can use. All right. So with all that said and done, do we have any additional questions? No other questions? All right. All right. So if there are no additional questions, then we can continue, not start, we can continue with the homework assignment. So let's go to the homework assignment that was due earlier today, and then we'll take a look at, how that is supposed to be done. And I'm giving you guys a new homework assignment, which is the by reference and value. That one is due next Wednesday. As usual, next Monday we'll have a online, not online. I will be here in person to kind of have a lecture just like usual. I have it recorded and upload just like usual. But I typically now have maybe 3 people who come consistently during the live lecture. Um, and I personally think it is actually helpful to be here in person so you can ask questions in real time. But it is not, this is a hybrid class, so technically speaking, I cannot require people to be here on Mondays. Okay. But if you think that you might benefit from a face-to-face lecture on Monday, you're more than welcome. All right. This homework assignment is not long, okay, unlike Fibonacci, which is a little bit on the long and gnarly side. Um, so try to do it, as soon as possible. If you have questions, bring it to the class on Monday or send me an email or something like that. That would be helpful too. So we're going to go back to Fibonacci and take a look at this homework assignment. Unless you guys, unless you guys, you'll basically say, okay, we don't need that. Then I don't have to go over it. So shall we all go over the Fibonacci homework assignment? Okay, I see nods. Okay, very good. All right, so we are going to take a look at this homework assignment. Okay, Control C. The first thing I will do is actually to run it first, okay, because I want to make sure that everything is self-consistent and the program can in fact run. So I'm looking for a terminal right now that is suitable. I can just make a new one. That's okay. All right. So we're going to use this, command line interface. Go to the temp folder, and you'll just create this program right there. Paste the whole thing. So gcc-d-o fib.c, and I can bump up the font size like that. Okay. gdb fib, list the program, and run it all the way to line 12, which is the return 0. Print x. X has a value of 2. So what this is helpful with is you can at least cross-check whether if your result does not store a value of 2 into x, that means you might need to go back and retrace the steps a little bit, okay? You can also single step through the program to kind of know how the logic flows, so that can be helpful too. But GDB does not give you the trace, okay? It doesn't give you what you need to turn in for your homework assignment. So that's what we're going to do by hand in class. So we're going to go to the home folder here, and then we go to shared, and I'll create the trace itself. So new Google Sheets, okay, and rename it. So if you have not been revisiting the traces that have been doing in the past, you might want to consider doing that, okay? Because that might be actually be helpful. And all these sheets that I have created, you can always make a copy on your own, and then you can just annotate it, you can print it out, bring it with you in a final exam, perhaps even, okay? So you can do whatever you want, once I have created the spreadsheet. All right, so we are going to go to the source code. Okay, so we're going to, let's see, we can do a mouse pad fib.c just so that I can capture the um. Okay, we can get this one out of view. I just need to do a print screen so I can view the code while I work on the trace, like so. All right, so that's good. Put it up here. Go back to the spreadsheet. All right, so are we ready to kind of trace it? Okay, cool. So as usual, we need one column for comments because there's one single condition of the entire thing. So that's why we need column A. We have line number. The precondition has nothing to say anymore because we do not have global variables. So we get to line 9, doesn't really do a single thing. Get to line 10, we reserve a column. Okay, the leftmost available column is now reserved. Give it a label of x, start with an unknown value. We get to line 11. which is going to, we need to make a call, okay? So we'll go ahead and shrink the column width just so that we can show more columns. So because line 11 is an assignment statement, in other words, we need to figure out what is the right-hand side or what is the value of the right-hand side on line 11. Whatever that value turns out to be, we use it to update variable x. So that means I need to figure out what is the return value of fib3. Okay, so that means we need a function call. And because that function call has a return value, we need return info instead of return line number in this case. So the return info has to tell me which line I'm supposed to get back to. That would be line 11, because by the time I get back to line 11, I can then finish the assignment operation. I can then update the left-hand side. So we have to go back to line 11. And what is left to do is the assignment operation. The question mark is a placeholder for the function call that has a return value at some point. And then we also have to reserve another column for the parameter of fib, which we call n. So we can see that the argument of 3 is passed to the only parameter of n. So parameter n, it has a value of 3. So that's how we set up two columns in order to call function fib from main. Once we get to function fib, which is on line 1, which doesn't do a single thing, we get to line 2. Line 2 has a simple expression to evaluate. Is n less than 2? What do you think? It is false, okay? Because n has a value of 3 right now. 3 is less than 2 is false. And as a result, we go to line 5. So line 5 is a return statement. Line 5 really just wants to return a value to the caller, but it can't do that because it has to figure out the sum between fib of n minus 1 and fib of n minus 2. So you can evaluate that addition from left to right or right to left. Okay, so the order actually does not matter in this case. So, but I usually just want to evaluate things in the order that we read, which is from left to right. So if you evaluate from left to right, so that means the first thing we need to figure out what is the return value of fib of n minus 1. So we need to call fib again. So whenever you call fib, you need a return info because it returns to the same line with additional stuff that you need to do. So now we have to return to line 5. When it is done, okay, when this particular function call is done, the function call on the left-hand side of the plus or the addition is going to become a single particular value, but the other side is not changed. So this question mark is replacing fib of n minus 1, but fib of n minus 2 still needs to be figured out. So that's how this return info is supposed to look like. Every time you call fib, you also need to pass an argument to parameter n. So in this case, parameter n is going to be the current n, which is a 3, minus 1, which is a 2. So you need to put a 2 here. So after you set up all the columns, you can now continue execution at the beginning of whatever function we're calling, which turns out to be the same function that we're in, but it doesn't change how we do it, okay? So we go to line 1 again, we get to line 2 again, uh, n is less than 2 is now false, right? Because 2 is less than 2 is also false. So that means we have to go to line 5 again. When we get to line 5, kind of a similar deal, okay? Not exactly the same, but similar. We still need return info, and we put exactly the same thing inside the return info because it's the first time we get to line 5 in this invocation of the function fib. So you still have to kind of do the same thing, return question mark plus fib of n minus 2, and then you have n as a parameter. This time n as a parameter, which is based on this particular n here. So 2 minus 1 is going to be a 1. So now we just kind of make it look nicer by reformatting a little bit. And then we continue execution at line 1 again. We get to line 2. Aha! What about this n is less than 2? It is now true. Very good. So if it is true, then we get to line 3. We execute line 3 right away because line 3 does not have any recursive call to fib, so we can evaluate the expression n right away. So what is the value of the expression just n on line 3? It's one, exactly. Okay, because even though we have multiple columns, they're all labeled n. Which one do we use? The rightmost available, the rightmost column that is labeled n. So that's just one. So that means we're executing a statement of return one. What do we do when we execute a return statement? hmm Yep, you copy and paste, and then you replace the question mark with the value that we are returning, which in this case is one. Okay, and then what do? We skip one row, and then we put this whole thing over here. Okay, because this is a reminder of when we get back to line 5, what else do we have to do? Hmm? Yeah, we are still executing line 3, so we are not done with line 3 yet. Yeah, that's okay. Well, there's one more thing we need to do when we execute a return statement. Exactly. That part is actually really important because we will end up reusing these two columns. Okay. So now we have to, indicate that these columns are not used, they're deallocated at this point. Okay. So it's really crucial to remember to say, oh, column H and column I are no longer in use because that particular invocation of fib is now done. Okay. So by the time you execute a return statement, you're basically saying we are concluding the invocation of a function. But you can have multiple invocations at the same time, which is what we are seeing here. All right, so we are back to line 5, okay? But this time, when we get back to line 5, the left-hand side of the addition is already resolved. We just have to resolve the right-hand side, which means we have to call fib again, which also means we have to reallocate the leftmost available column, which is now column H. So we say, oh, okay, we're going to have to reallocate this also for return info purposes. When we are done, we're supposed to go back to line 5 again. But this time, when we get back to line 5, we still have the 1 and we still have the plus. But the function call is going to now resolve to a particular value. So this is how we write the return info when we get back. Every time you call fib, you also have to specify parameter n. So now, what is the value of this n of column I? It's 0. Very good. Because when we look at n minus 2 over here, this n is referring to the n that is already known, or I should say the rightmost column that is labeled n that has a value. That's column G. Column G has a value of 2. 2 minus 2 is a 0. So that means this n is getting a value of 0. There we go. And now we continue execution at the function or at these at fib. Line 1 doesn't do a single thing. Line 2 is asking the question. N is less than 2 is true because n is 0 this time. And we get to line 3 again. Line 3 says we just want to return the value of n. Okay, the rightmost column that has a label of n is has a value of 0. So we are returning 0. The action of returning 0 means we look up the rightmost return info column, copy and paste, Control C, and then paste, and then you change the question mark to the value that we are returning, which is in this case is a 0. So we put a 0 there. But don't replace 1 plus 0 with a 1 yet, okay? Because we are not executing this statement. And then we also have to do the usual thing, which is deallocate both of the columns because every time you execute the return statement, it also means that those columns are not useful anymore. And then we also want to remind ourselves what else do we need to do by the time we get to line 5. So now we get back to line 5. After deallocating the columns, we get back to line 5. Can we execute this line 5 as a return statement? Can we figure out what is 1 plus 0? Yes. Okay. 1 plus 0 is just 1. So that means that we are now executing return 1 plus 0, okay, which is returning 1. What do we do when we execute a return statement? The same boring stuff that I've been talking about, right? So we look up the rightmost column that is labeled return info. Oh, okay, it's this one now. It is now column F, right? So we copy and paste this over here, and then we say, oh, we know what the return value is supposed to be now. It is returning a value of 1. That's all we do. And then we copy and paste it over here. You can either use a formula in the spreadsheet, or you can just hand copy the whole thing. Doesn't really matter. And then we deallocate the columns. Column F and G are now deallocated. And then execution continues on line 5 again. Are we still good? All right. So can we execute the return statement right now as it is? No, because the right hand side of the addition is another call to fib. So we have to deal with that function call first. So when we call a function, same thing, right? We allocate the leftmost available column. So what is the leftmost available column right now? Column F. Very good. So column F is now reallocated to remember the return information. We have to go back to line 5. We still have to do the return thing. We still have to do the addition thing. But whatever fib of n minus 2 turns out to be should become a single value. But every time you call fib, you also have to specify parameter n. So what is the value of this n at this point? You probably need to scroll up a little bit here. Yep. So it will be this 3 minus 2. So that's 1. So, oh, I just put the label on the wrong line. So this is 1. So after you set up the columns, then you continue execution on line 1. Doesn't do a single thing. Line 2 evaluates the condition. 1 is less than 2 is true. So we go into the then statement on line 3, which is returning just the value of n. N has a value of 1, so return n is return 1, which means what we do is we look up the rightmost return info cell, which is this one here, copy and paste it, change the question mark to a value of 1, and then we do the usual thing. Okay, we copy this entire cell to one row below, just to remind us by the time we get back to line 5, what else do we need to do? And then we indicate that these columns are now deallocated because if we have just concluded another invocation of fib, and now we get back to line 5 again. But this time when we get back to line 5, we know how to evaluate 1 plus 1, which is 2. So this is basically executing the return to statement. Return to statement says we have to retrieve the return info cell from the rightmost return info cell. So we retrieve this one, we copy and paste it down here, change the question mark to the value of 2 because that's what we are returning. And then we do the usual thing, copy this cell over here, conclude that these two columns are now deallocated, and now execution gets back to line 11. Can we execute the assignment operation now? Yep, because the right-hand side is fully resolved to a concrete value of 2. So now we look up the rightmost column that is labeled X. That turns out to be column C. So now we update column C to a value of 2, move on to the next statement, which is line 12, which is a return 0, and that concludes the execution of the entire code. So the important part of this trace is the shape of the trace, okay? So when we look up here, and I can just kind of, let me see if it works here. It doesn't quite show that well, okay? So I'm going to shrink the um, spreadsheet a little bit just so that you can see the shape. So that is the important part. It grows, it retracts just a little bit, it grows again, and then it retracts a little bit more, and it grows a little bit more, and then it retracts all the way back to the beginning. Okay, all right. So do we have any questions about the trace of the Fibonacci function? No questions? All right. All right. So for people who are having some questions about this, okay, um, my question is how much time do you spend on studying for this class? So that's one, okay, do you have enough time to study for this class? And then question number 2 is how do you study for this class? So there are two separate questions. Do you have enough time? Number two, how do you do it? Okay. So for question number one, what is the answer? How much time should an average student allocate for a class like this? Let's just say on a weekly basis. Hmm? Say again? 3 to 4 hours. Okay. So I would say that's about right. Okay. Because we meet, so including the recording on Monday, okay, we have 160 minutes of lecture. Okay. The formula is for each hour in lecture, you're supposed to spend 2 additional hours to kind of absorb the material, go to my office hour, talk about the topics, do the homework assignment, and so on. So that means 320 minutes are supposed to be added to the 160 minutes of the actual lecture. Oop, what are the chances, right? Okay, so now we have um, basically that's that's the number of minutes. Convert that into hours. You guys can divide 60. 320 minutes divided by 60 is 5 hours. Yeah. Okay. Let me double check my math. Okay. That sounds a little. This is one and third of an hour. So this is 1.66. And then when you multiply that by 2, you get 3.33. Okay. My math is not working. Oh, okay. My math indeed is not working because 160 divided by 60 is 2 point something. So this is actually 2 point what? 160 divided by 60 is 260, and then 120. We have a 40 as a remainder, so it's 2 and 2/3. Okay, so this is about 2 and 2/3, close to 3 hours. So that means the the amount of time that you need to spend to study for this class is about 5 hours, and that's on a weekly basis. Okay, so that's the first thing. Okay, is the scale. Now, you might say, but Tech, you're just a particularly nasty professor. Most of the other classes, I don't need to spend that much time. Well, for GE classes, I cannot say. For computer science classes on the track of CISP, I'm going to say that's probably a reasonable assumption for all of the classes that you have to take on this track. Okay, I really need to let people know the realistic expectation, right? How much time do you need to spend to study in a class? So what about the how part of studying? How should people study for this class? So you can review the lecture video. You don't have to watch everything from start to finish. You can just go to the parts where you go like, I'm not really quite getting this, right? So how do you know which part you're not quite getting? Okay, I see you are doing a really good job because you have a notebook, right? You're jotting down notes, okay? And part of that notes can be, oh, the professor said this, okay? But that part usually you don't have to record, but because I'm recording everything. So what do you write down in your note? Go ahead. How I explain it? Yep, things that are interesting, which means you think they are somewhat of value, okay? Something that you might need to go back and think about a little bit later. So that is the important part because you cannot rely on your short-term memory to do all that because of what? What is special about short-term memory? Because it's short-term, okay? Did I mention how short-term your memory is? If I do not refresh, okay, in other words, if I do this trace here and I only mention once how to perform the return operation, and it's the first time you encounter that concept, how long can you retain that instruction? 20 seconds, okay? The reason why you do not feel like that is because I have been repeating that. Okay. This example by itself has how many times did I return? You just count these, right? One, two, three, four, five. Okay. So because of that refresh, because I keep mentioning the same thing over and over again, you don't feel the short-term aspect of short-term memory. But if I only mention it once, okay, you cannot remember after 20 seconds. That is why note taking is really important, especially in a class where there's no recording of the lecture. So now you have to ask, how many professors actually record their own lectures? Exactly. Okay. Yeah. Most students that I have asked in my more advanced classes, like 440, they said that I'm the only person who record the lectures. So that means without a recording of the lecture, your notes also have to include whatever the presentation has on the projector. So that means you're gonna you will be quite busy taking those classes because on one hand, you have to capture everything on the whiteboard and also on the projector. On the other hand, you also want to record everything in your own mind. Okay, so that takes a lot of effort. This class is a little bit easier because I'm recording everything already. If you see on the projector, or if I'm saying it, it is being recorded. So are we doing okay so far? Okay, this is your first class in the entire computer science sequence. So, I want to make sure that you are ready for the next few classes. Okay, you know how to take notes, you know what you need to do in the class. I don't, I know I sound like nagging because I am nagging, okay, because I have children about your age. They're actually slightly older, okay? So when I see you guys, I go like, okay, I have to switch to nagging mode. So if people do not like me nagging, I apologize, okay? But that's just part of my nature. All right. So shall we move on? Okay. All right. So now we are going to move on to the next homework assignment. Okay. So I'll just kind of take a quick look at the homework assignment, and I think that's probably what I will do. Is to conclude the class with just a quick look at this homework assignment. So it's called by reference and value. So there are basically two ways that you can pass an argument to a parameter. So in this case, we have those two. One is passed by reference and the other one is passed by value. So you kind of have to remember what passing by reference means and what passing by value means. Okay. Now with this particular program, you can actually run it too. So you can use GDB to run it and then figure out by the time you get to the return statement, what is the value of Z and what is the value of V and what is the value of W. Okay, so you can at least cross check to see whether your trace has the correct answer. It is not going to be a very long trace. Okay, I can even tell you how long it's going to be. We get to main, we create local variable v, we create local variable w, and then we create z. We assign the value to v, we assign the value to w. We call compound add. Compound add only has one single statement here. We do the return statement. We get back to main, and then we return a 0. You don't even need a comments column in this case because there are no conditions to evaluate. Okay, so this is a relatively short trace, which does not make it easy because the key concept that I need you to practice on with this one is differentiating what does it mean to be passing by reference and what does it mean to be passed by value. And both of those concepts are in a particular module. So this brings us back to what you need to read in order to understand those concepts. So this is parameters. It talks about passing by value versus passing by reference. So I just have to open this up so you can see right here, passing a parameter when by reference, when referenced. Um, Another kind of parameter, I think that is when we specify passing by reference. So, so there are full traces, finished traces in the module itself to help you understand what it is and also what the trace looks like. Okay, so if you have not read the module at this point, it probably is a good way to start. Okay, it's a good way to start because I even highlight the C. You can see how column C, the C is highlighted in red, and also how the reference itself is also highlighted in red. That is my visual cue to let you know this is how it's done. We have also talked about this in lectures already, so going back to figure out which lecture talks about this and possibly re-watching that video can also be helpful. So are we good so far? All right. So this is one of the few days when I will let you guys go a little bit early. Okay, it's about 10 minutes. But I will still be here because I have my next class. So if you have any questions that you want me to answer after class, I will still be here. If not, have a happy Thanksgiving. I'll see you all on Monday or Wednesday, depending on whether you come to my optional lecture today, lecture on Monday or not. Yeah, let me stop the recorder first and then